we go. Okay. Welcome everybody. So tonight we have on the agenda, we'll run through some of these for you to take away. We'll talk about what is cross-site scripting. We'll give a bit of an explanation on that. We'll talk through different types of cross-site scripting. We'll talk about the impact. We'll talk about how to identify vulnerabilities, what you can do to defend yourself against cross-site scripting attacks, and we'll finish off tonight with a question and answer session with Alex Miller, who is an offensive security analyst. So what is cross-site scripting? Cross-site scripting attacks occur when data enters a web application through an untrusted source, most frequently a web request. The data is included in dynamic content that's sent to a web user without being validated for malicious content. The malicious content sent to the web browser often takes the form of a segment of JavaScript, but can also include HTML, Flash, or any other type of code that the browser may execute. The variety of attacks based on cross-site scripting are almost limitless, but they commonly include transmitting private data like cookies or other session information to the attacker, redirecting the victim to web content that's controlled by the attacker, or performing other malicious operations on the user's machine under the guise of a vulnerable site. So we talk here about reflective or DOM cross-site scripting, and we'll go on and explain a bit more about different types. There's stored as well, we'll come on to that later. But for reflected or DOM, we'll kind of explain quickly what is meant by DOM. It's Document Object Model. It's a programming API for HTML and XML documents. It defines the logical structure of documents and the way a document is accessed and manipulated. Within the document object model, programmers can create and build documents. They can navigate their structure, and they can add, modify, or delete elements and content. Anything found in an HTML or XML document can be accessed, changed, deleted, or added using the DOM. So in this example that we have here, the attacker crafts a hyperlink containing JavaScript. The link is then sent to the victim in an email. The victim is conned into clicking the link in the email, which takes them to a website that contains malicious JavaScript. The script is executed, potentially allowing the attacker to carry out additional actions, and we'll touch on these later. Now we have some demos that we'll run through showing these concepts using Juice Shop, and Emily's going to take us through them. So over to you, Emily.
Thanks. So I'm just going to quickly share my screen, and as with all live demos, my Juice Shop has just crashed, so I'm currently restarting it, so bear with me. So hopefully everyone was able to get Juice Shop installed. So if you haven't, have a look on the meetup link. It will give you some instructions of where you can go, and there's also some other YouTube videos that the other chapters have uploaded onto the latest Hacking Cypher channel. So as you can see, it doesn't look like it's started. Let me just do a quick check. Nope, it doesn't usually take this long, so let's give it another shot. If this doesn't work, then I'll hand back to you, Nicola, and we'll do the demos at the end so we can cover the next type.
No worries.
Okay, here we go. That looks better. I jinxed it by saying that it wasn't going to work on LinkedIn. Okay, we are up and running. So the first demo that I wanted to do was actually covered on the last session that LHS ran. But for those of you that weren't able to make it, I just thought it would be useful to go over how to find the scoreboard, because anyone that is new to Juice Shop is going to want to know basically what the hell am I meant to be doing, because that's the first thing that I was like when I opened it. So the scoreboard is the part of Juice Shop that lists out all of the different challenges that you have to complete in order to work your way through the vulnerability testing. So the first thing that I did, so this might not be the way that everyone else does it, but this is just how I did it, was I opened it up and I just had a little bit of a play around and look at what was available. So we've got the side menu, and then it gives you some options that you can select. So I literally just went through and I was looking at the URLs and clicking through the different pages that we can see. And it's crashed again. Here we go. Okay, so these are the different pages that we have that are available on the side menu. And I thought that this one looked fairly unique because it had a hyphen in it. So I thought that this would be a pretty good pivot point for me. So if you hit F12 on your browser, then you can bring up the debugger, the inspection tools. So in here, we have a few different files, and I was interested in the main.js. When you first open it, it's going to be really ugly like this, and everything will show up on one line. Depending on which browser you're using, you can then get it to pretty print, and that's what brings it up into the different lines.
Could you zoom in a little bit to the right one?
To the right one.
The inspection. Development.
I don't know how to zoom.
That is fine.
Is there a zoom? Anyone know how to do it?
You can try the control and plus sign. It might work. Oh,
there.
Nice.
Here we go. Cool. Good shout. Okay. So this brings up the JavaScript file. So we know from over here that we've got a path or a URL that's photo wall. So literally all I did was Control F and then photo wall, so photo-wall. And then I was just looking at where this appeared. And then the second one actually takes us to something that says path and photo wall. And then I was looking around it and you can see other things that look like they might be pages inside the web app. So I literally just did a scroll up and a scroll down to see what else was existing, and then saw, oh, my eyes are deceiving me. Here it is, scoreboard. So I thought, that's interesting, copy that, replace photo wall in my browser with scoreboard, and with any luck, that is how you solve the first challenge in the Juice Shop. So you can see we get a nice screen box to say that we've solved it. So then the ones that we're looking at this evening are XSS. So you can see that there's loads down here. So your pre-selection is going to be 1 star, and then it's going to show you all of the 1 stars. But for the purposes of this evening, we're just going to look at XSS, and then I wanted to see what was available all the way through. So you can just click your stars to show those. So for this demo, and because this is my first attempt at doing this, so if anyone on the call or following on YouTube is doing this for the first time, you are not alone. So I decided to pick the easy 1 stars to start with. So the first one that we're going to do is the DOM XSS. So Nicola's already mentioned that this is where we're trying to inject some JavaScript, and in this case, they've given us what we need to inject, and we want to put it into the DOM. So we know that we need to place this somewhere on a web page where it's going to be reflected back to us. We know that because it's a type of reflected. So we're looking for some sort of user input into the website where the thing that we put in is shown back to us. So again, I just sort of went hunting. So the first page was this, so customer feedback, and I just had a play. Whoops, that's not how you spell test. And then putting in your captcha, so maths on the fly, 41. So
may I ask a question?
Absolutely.
You said we know it's reflected. What did you mean?
Yes, so reflected is when the thing that you're telling it, so you're able to give it a variable, you're giving it some text, you're giving it a string, and that then gets reflected on the web page. So it gets sent back and displayed on the website. So we're looking for something where we can input some text, do something, and then that text is shown back to us. So this would have been a great example if it had shown that text back to us. It hasn't, so that was a dead end.
So you understand it by trial and error, or is there a way to know it easily?
I'm sure there probably is a way to know it easily, and you could possibly search for it in your JavaScript. This was the first time that I had done it, and this is the way that I did it. But if anyone on the call wants to pop in, if there's a better way of doing it.
Certainly, there are scanners that you can use to search HTML and crawl for JavaScript that might have DOM-based vulnerabilities. There are also methods just manually searching, as Emily's explained, looking for input fields, looking for HTTP GET requests where potentially it's taking parameters. So you can do it both manually and automated.
I see.
Thanks, Alex. That's why we invited Alex, our offensive security analyst, to join us this evening, because neither Nicola nor I are offensive security. So yeah, so again, I was literally just clicking around, seeing what was what, and then actually stumbled upon one of the other challenges, which I think will possibly get covered at another date. But you can click into lots of different things. We obviously already looked at the photo wall, scrolling around, and then notice the search bar, right? So big the moment. So the first thing I did was I like test. So I typed in test. Okay, so we can see that the string that we've given it is now being reflected back to us on the screen. So we typed in test, and the website is now showing us test. So I know that this is HTML. So the first thing that I do is I added in a bold tag to see whether or not there was any input validation going on that would stop me from manipulating the HTML. So when I did that, we now obviously have nothing coming back because it's searching for the string with the tags. But we can see here, it's not hugely clear, but you can see that it has been bolded. And then I was just having some fun and changing it using different tags to see what happened. Just having a look around and seeing, right? So we know now that we're able to put in here some tags and manipulate the text that's coming back to us. So if we go back to our scoreboard, because obviously I didn't copy that what we needed. There you go. Okay. So it's this one that we're doing, and it's this that we're trying to get it to display. So what this is trying to do is embed an iframe into where we're seeing text being displayed, and it should give us a pop-up with the text XSS in it. So that's what we're expecting to happen based on this piece here. So if we go back to our page, so this is where we're displaying our information, and if we paste this into here and hit enter and cross our fingers, okay, here's our XSS box. So that's the alert box that we're seeing, and you can actually see here that you've got the iframe as well. So the other piece that I thought would be useful, so Nicola touched on, she touched on what attackers might like to do with this type of thing. So what I decided to do, just to see, I was just messing, was to see whether or not we could display some of the variables. So let's see if we can display the cookie. So document.cookie, and let's see what happens when we run that. Okay, so this is where it starts to get interesting, right? It's where you can start to manipulate what's being sent back to you. And you can now start to appreciate how attackers might use this to access things like session tokens and hijack sessions. So I thought that was really interesting. So let's have a look at what's actually happening here. So let's go back to our inspector. So if we go to the page inspector, so the page inspector should be giving us the document. Let's just make sure we're on the right page. Inspect. Okay, and then we know that we're looking for our iframe. So let me, oh, I'm on the wrong. Okay, so here it is. So this is what we've done. So we know that inside of this tag, we've inserted our iframe. And what's interesting here is that we've got the ID, so search value. So then what I did was I had a look at copying this, so search, and we go back into our debugger, which should give us why is it not doing it? Let's close that and reopen it. Okay, it's back again. So then we do, and it was, does anyone remember what it was? Was it search value? Okay, so now I'm searching. I know that the ID was search value. So we're having a look at just what exists for this. Okay, so this is interesting, mostly when you can see all of it. So here we've got what is happening, right? So the thing that I noticed that was interesting and I knew nothing about was this here. Bypass security trust.html. So
I don't literally seeing it. Oops. I have lost your screen altogether.
Okay.
Is that just me or Nicola?
I've lost it too. Yep.
Okay.
Happens. Okay, so apologies for the slight technical hiccup there. So yeah, so what I've done here is searched for the ID, which was search value, and then I noticed this line that was interesting, and I didn't actually know what this did. So Google is your friend in these instances. So I literally just went into Google, I pasted it in. Let's have a look, see what it says. Okay, so on the Angular documentation, this is probably a good place to be looking. So waiting for it to load, and we can see that it's something to do with the DOM. And it was bypassed security trust HTML. So this one. So this one here that we're looking at. So bypass security and trust, the given value to be safe HTML, blah, 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 blah. Really interesting warning at the bottom, right? So calling this method with untrusted user data exposes your application to XSS security risks. So that's exactly what we've seen happen there, right? So there's no validation of the user input. So we've got untrusted user input, and that's what's exposed the application here to cross-site scripting. So yay, that is number one done. So the second one that we're going to do is the bonus payload. So this is literally exactly the same as the first. And the reason that I'm showing it to you will become particularly apparent when I paste this in. So let's copy and paste it. So we'll go back to our search page. Paste it in. Can everyone hear the jingle? That's the most important question.
Yeah.
Okay, so while this plays, I'm going to talk over the top of it because it's super fun. But let's go back to the what we've pasted in and have a look at what we've done here. So again, we have loaded an iframe, just some parameters about the iframe, and then we've told it that we want to autoplay a file from SoundCloud. And it is this awesome jingle that made me chuckle quite a lot once I've done it. Just don't test the site with burps. You won't like what you see. So I think we'll probably save the rest of that, and we'll do maybe a play out at the end so that everyone can. But yeah, no, super fun. And I'll admit, when I was doing this, I was just copying and pasting. I wasn't paying attention to what I was pasting in, so it was a nice little surprise when that popped up. So the next next demo that we'll do is the 2-star. So let's go back and have a look at what that is. So this time we're going to do some reflected XSS, but not DOM XSS. Okay, so we need to perform a reflected XSS attack with, again, so we've got this same piece of code here, which is an iframe that's going to generate an alert box and display XSS. Okay, so this time, because we're not putting it in the DOM, we need to find somewhere where the URL at the top is going to display something, and then that's going to get reflected back onto the page. So rather than it being an input, it's going to be something that we're doing up here, and then it's going to display. So again, I'm sure there's probably better ways of doing this, but I was just literally playing around, clicking on stuff, and just really exploring what the site could do. So I pretty much exhausted everything that I could do through this menu. So the next thing was logging in, right? So you can see here, I have reset it though, so those won't work. So the first thing I did was, I'm not going to try and hack the site. I'm just going to try and create an account and see what happens. So creating an account, again, I like test, but you have to have 5 characters for the password. Select your security staff, test. Again, just always keeping an eye on the URL. So again, nothing that we're typing at the moment seems to be doing anything up here. So then we can log in. Okay, so now what options have we got? So we're back on the products page. Okay, so now we've got a profile. So we can have a look at the profile. So again, nothing that's up here is showing down here. But these are all really useful things, typing in some stuff, seeing what happens. Skip through this because I've done it, it wasn't helpful. So the next thing was orders and payments. Okay, so order history, what have we got here? So we don't have any orders. So I thought, let's create an order, see what happens. So back to the shop, and we'll add some stuff to our basket. I was sold by the only one left. I was like, oh, gotta get that one, gotta get that one. Right, okay, so let's go and have a look at our basket. Okay, so we've got some stuff. Again, nothing up here is showing down here. So we'll try, and that's really expensive for some juice shop stuff, but let's go for it. Okay, and we're gonna get some bonus points. That's always appreciated. Okay, so now we need to select an address, but I haven't got any addresses saved. So we just have to create some stuff. We are in Scotland tonight because it is the Ladies of Glasgow Hacking Society. This one caught me out because there is some validation on this. So if you don't put something that looks like a mobile number, it falls over. Again, you can see here we've got some input validation. So it's looking for something that's 8 long. And some addresses, we'll just test. City, Glasgow. Okay, so we just go through the motions of creating stuff, watching the URL, and seeing what happens. I don't know about everyone else, but I always want my stuff next day. If it isn't on Amazon Prime and they're not going to deliver it to me either that day or next day, then I don't want it. So we'll click through. Okay, so now we need to pay. I am going to go off on a tangent here because I actually saw this and I was like, I don't need to put one in, but I really want a coupon code. And then when I went back to the scoreboard, I noticed that there was actually a challenge to try and get yourself a discount code. So I thought I can totally do that. I'm not buying anything full price, even if it's fake. So my first port of call was I saw that there was a support function. Nice to meet you, Tess. I am Juicy. Hi. Give me a discount code. So we know that this is a chatbot. So my idea was just keep asking the same question over and over, and see if it had anything in its code, which might enable you to break out of it, right? Maybe it's got some sort of loop or something in it. I did go and look at the code on GitHub for it, but I'll be honest, I wasn't able to find the piece of code that actually breaks it. It does seem to be arbitrary how many times you have to ask it. And I will admit, I'm not going to do it on live, but I did start using some swear words while I was doing this. Whoops, it helps if you can spell. Last time I did this, it took 3, so.
We could be here sometime, right?
We could be. I'm going to go for one more and then I'm going to give up. No, okay. But basically, if you just keep doing that, it eventually gives you one. And the challenge is called bully the chatbot. But yeah, okay. So then you can paste that in here and you can get yourself a discount code. So we need to add ourselves a payment method. Again, I like test, and I think that this has to be 16 digits. Whoops, I can't count. So we're just going through the motions, always watching the URL, submitting what we can. Okay, so now we've got a card loaded. So this is our order. We're going to place our order. Okay, so we now have an order in the system, so we can go to our track orders page, which is where we started all of this, and see what we have here. Okay, so this is interesting. This is actually what we were looking for. So we have here a ID, so a variable that's being passed through in the URL, and that is being displayed on the screen. So that is an example of reflection, right? So you have some text up here and it's just reflecting it back onto the screen, back to the user. So I shouldn't come off the scoreboard. So we go back to our scoreboard. And we are looking for our reflected. So here we have it. So let's try pasting it here and see what happens. Nothing. And that confused me as well. And then I hit F5. And there we have it. So same thing again, right? So we've got our alert box being loaded. You can see your iframe in the background, and we have successfully solved the challenge, reflected XSS. So I thought that was actually a really interesting, because I'd only ever really done cross-site scripting in theory at university. I've never done it in practice or seen it in the wild. So I thought it was a really, really interesting exercise to go through. I'm sure there are better ways of doing it, and I'm sure Alex, who's on the call, will be watching that thinking, oh my God, you did that the longest way possible. But I just wanted to show you that for people that haven't done it before, trial and error is just as good a way to get you started. And then you can start looking at the JavaScript, you can start looking at the source, and you can kind of do it backwards. But I think that is the end of the demo. I am just going to check Oh, no, so the last thing that I was just going to show was going back to the page inspector. So let's inspect this page, make sure we're on the right one. Again, Control F, I know that I've got my iframe in there. So here we go, again, we've got our iframe. So we can look at the code, the code around it. I've lost it again. Anyway, you can look at the code around it, you can see what's going on, you can take it back to the JavaScript, which will give you that same Angular warning, which is basically don't use the bypass security trust HTML. And that is the end of the demo. So Nicola, I will hand it back to you. Let me stop my screen share.
That was amazing.
Yeah, thanks very much, Emily. That was really good.
And also the methodology was great. I've no criticisms at all. So just wanted to confirm that the silence wasn't a criticism.
Thanks. I'll send you the check post later.
Some juices. Send her some juice from the juice shop.
Okay, I need to share my slides. Okay, so thanks Emily for taking us through those demos there. That was really good. We'll just pick up then on the slides. I think the next one we're going through is looking at stored cross-site scripting. So in this example that we have here, the attacker injects malicious script into the web server. The code is saved into the database. The victim then visits the infected web page and makes a call to request data from the database. The action then executes malicious code into the victim's browser, and the attacker then gets hold of the victim's data. So the difference between this one and the DOM cross-site scripting that we looked at earlier is just that this one is stored in the database, waiting for the victim to visit the infected web page. And then as soon as they make a call for data from that database, the code is executed and the attacker gets the data as they're looking for. So that's that example. What is the impact of cross-site scripting? So here we talk through different examples of why an attacker might want to execute malicious code and carry out cross-site scripting. So session hijacking is one example. Session hijacking, or sometimes also known as cookie hijacking, occurs when a user session is taken over by an attacker. If the attacker gets hold of your session ID or your cookie, they can essentially log into your account and can do anything that you are authorized to do within that account, such as purchase goods, access detailed personal information, and even empty your bank account. The repercussions can be even worse for organizations because cookies are often used to authenticate users in single sign-on on systems, meaning that a successful attack can give the attacker access to multiple web applications at once, such as financial systems, customer databases, and valuable intellectual property. Needless to say that no good comes of session hijacking, regardless of who you are, whether you're an individual or an enterprise. Redirection as well is another example. Redirection is a common use of reflected cross-site scripting, as we just kind of looked at there, where the victim's browser as a common use of reflected cross-site scripting is to redirect the victim's browser to another website that mimics the look of functionality of a legitimate website that the user thought that they were visiting. This can result in the attacker acquiring the user's logon credentials. We often see this via phishing attacks, where a victim is sent an email containing a link that has JavaScript injected into the URL so that the domain appears to be trusted, and then the malicious JavaScript redirects the victim to a page that's masquerading as the real deal. Keylogging is another example that enables the attacker to record all the keystrokes that's used by the victim. So they monitor what the victim's doing. A keylogging script can be injected into websites that are vulnerable to cross-site scripting. The script tracks user key presses by concatenating each key press into a string that is then posted to a log file which the attacker can access. So using this technique, usernames, passwords, and other sensitive data can be captured. The last one we look at here is user interface redressing, or clickjacking, as it's also known. It's used to trick unsuspecting website visitors into performing actions on another website, i.e. a target website. For an example, a user might be attracted to a website that's offering a prize giveaway. When the user clicks to accept the prize, their click is instead used to purchase an item in an e-commerce website. Typically, the attack is performed by hiding the target website, the user interface for the target website, and arranging the visible user interface so that the user isn't aware that they're actually accessing the target website. Because of this deception, the user unwittingly performs operations like transferring money, purchasing products, and downloading malware. Yes. So some ways to, there are various ways to identify cross-site scripting. Use various tools to do that. So yeah, it can be difficult to identify and remove from a web application. The best way to find flaws is to perform a security review of the code and search for all places where input from an HTTP request could possibly make its way into the HTML output. Note a variety of different HTML tags can be used to transmit a malicious JavaScript. Nessus, Nicto, and some other available tools can help scan a website for these flaws, but they really only scratch the surface. If part of the website is vulnerable, there's a high likelihood that there are other problems as well. So how do you defend against a cross-site scripting attack? It's essential that any web application that's been developed uses some form of security testing to reduce the number of security-related design and coding errors in an application, and to reduce the severity of any errors that remain undetected. A critical rule when developing applications is to assume that all data that's been received is from an untrusted source. This applies to data such as cookies, emails, files, images, and even if they're coming from authenticated users, you still trust them as an untrusted source. Another barrier to attacks is a crossing boundaries policy, where authenticated users have to re-enter their passwords to access further services. So an example of this is even if a user has a cookie that automatically logs them into a site, they're then also forced to re-enter their username and password before they're allowed to access any sensitive account information. This extra boundary can limit the possibility of a session being hijacked. Automatic source code scanning tools and penetration tests are also recommended to identify vulnerabilities or configuration issues before putting a web application live. And that is the end of the kind of slide pack on the cross-site scripting. So at this point, I'm going to hand back to Emily. She's going to introduce our lovely Alex that's come along tonight.
I have a question, but I'll ask it now. But if it's something Alex can cover, I can ask it again to Alex. So in the first few demos you showed, there was also in the inspect menu, I think it was calling a SoundCloud, so like an external site. Would a content security policy would that have helped that if I was the coder who was building that website?
I'll allow
yeah,
Alex.
so you can protect. Oh, okay. Yeah, Alex, you want to take that?
Yeah, there's quite a few security headers that you can use to limit the way that sites interact with external parties. The content security policy is probably the most verbose of all the security headers, and there's many different security settings, including ones about interaction with third-party sites. So that's definitely one way of approaching it. But it's one of those things where it's probably a defense in depth strategy. So while content security policy is great, the chance of that issue being used in a separate attack, not referencing another website, is still pretty high.
Mm-hmm. Thank you.
Do you want to, Emily, do our introduction for Alex before we move on to some further questions? Okay.
Yep, unless anyone has any other XSS questions, we can stop the recording. So last call for content questions.
Going for 3, 2, 1. And thank you, everyone.